Welcome to Technology in the Toolbox. I'm Mike Drone, and I'm excited for our team to be able to showcase a few examples of how facilities operations continues to adopt new technologies, automation, and data integration into our day-to-day operations. We hope this video will help you better appreciate how we are using technology to reduce cost, energy, and carbon while improving the campus environment.
Hello, I'm Doug Eklund, Assistant Director of Building Systems in the Wake Forest University Operations Group. We'd like to highlight some of the technologies we utilize to manage and monitor Wake Forest University buildings. Our connected systems utilize both server and cloud-based technologies. We also utilize other technologies that, while not connected, are very important in their function. The functions of our connected systems include energy management, climate control, energy metering, reporting, and dashboards, chiller plant optimization, indoor air quality, lighting controls, solar PV and hot water systems, fire alarm systems, and water treatment. In addition to the connected systems that fall under the facilities umbrella, there are other campus systems that support the operation of Wake Forest University. These include card access systems, campus security systems, the Workday platform, Deacon Space, and campus multimedia. It's important to note that many of the systems I've mentioned integrate together to provide enhanced campus functionality. Today, we will be highlighting energy meters, the Allerton building automation system, chiller plant optimization, copper tree analytics, Lucid, and a relatively new non-connected ion generation technology from Global Plasma Solutions. In response to COVID-19 in 2020, facilities and campus services deployed bipolar ionization technology in high-density areas. When combined with increased outside air ventilation, increased air filtration, longer HVAC equipment run times, and UVC ultraviolet lighting, the facilities team has strived to closely follow ASHRAE guidelines in the occupancy of campus.
Our patented needlepoint bipolar ionization technology safely introduces ions into the airstream, using the airflow in your existing ventilation system as the delivery method. When these ions disperse throughout a space, such as an office or a schoolroom, they combine with particles suspended in the air. This creates a snowball effect in which particles of opposite polarity begin to cluster together. As these large clusters pass back through the HVAC return, they're easier to capture in the filtration system. Our cleaning process is also effective against pathogens. When contact is made with ions, it disrupts many pathogen surface proteins, rendering them inactive. Other common indoor air pollutants include VOCs, or volatile organic compounds. There are hundreds of types of VOCs that are created by common household items, such as cleaning chemicals. Ionization is effective at tackling VOCs as well as odors, such as those lingering around nearby trash. Through our patented technology, VOCs and odors are broken down into basic, harmless compounds, leaving the air smelling more fresh and clean.
In this segment, I'll be discussing one of the features of the Lucid Energy Dashboard platform. The Lucid system records and stores our energy and water consumption data for each building. The data can be processed and visualized in many ways to provide valuable insight into how we are consuming energy and water on campus. From this main screen with selection windows, we can select the building we would like to analyze. All of our connected buildings are available from this home screen. From the left menu, we can select pre-configured apps that tap into our stored consumption data and display and compare it in many different ways. One of the apps I find very helpful is the heat map analysis in the analytics section. This is a heat map analysis of Farrell Hall, graphically showing the total building electrical use intensity over the last 12 months. The top of the chart is April 2020, and the bottom of the chart is February 2021. On the chart, the dark green bars indicate the lowest energy use intensity. As the energy use intensifies, the bars will change to green, to yellow, to red. The darkest red indicates the highest energy use intensity. Visually, you can see the point in April where we unoccupied campus due to COVID. There was some midday activity beginning in June and also some planned cycling of the HVAC equipment to circulate air. In August through November, you can see the reoccupancy of the building with the peak periods of energy use in the middle of the day. The green band showing the Thanksgiving break and a larger green band showing the winter break show our efforts in scheduling the building for unoccupancy.
My name is Tim Mitchell, and I am with the Building Systems team of Facilities and Campus Services. Today, I would like to show you a few aspects of how we use technology in the operation of the buildings. The first of these is what is referred to as building automation systems. These systems control heating and air conditioning as well as lighting. One of these systems is the Hoffman Building Technologies Allerton Compass Control System, which you see here on the screen. Our main page shows the campus layout. This system is installed in academic admin, athletics, res life, and other Wake Forest facilities such as Reynolda House, Grayland, and the President's House. I want to demonstrate how one of our technicians would troubleshoot issues in a building. Let's look at North Campus Dining. If we click on the main level floor plan screen, we can view the temperature and humidity data for the space. The green lights shown on the page indicate that temperatures are normal and near set point. If one of the temperatures was slightly out of acceptable set point range, the light would turn yellow, and if the temperature was further out of acceptable set point range, the light would turn red. We can view a summary screen of the zone data information. We can view temperature and airflow data in the zones and can determine if a zone is presently in heating or cooling. One of the features of the building automation systems is time scheduling. Time scheduling is used to maintain temperature comfort in the buildings while maximizing energy savings. Weekly, the building systems team consults the EMS reservation software or Deacon Space software that is used on campus by faculty and staff to reserve areas in buildings. We adjust scheduling to set back the systems when spaces are unoccupied. I will now show you what scheduling looks like for North Dining Hall. North Dining Hall is used each day during the academic semester, but during winter break and summer, the settings can be adjusted to set back for energy savings. Here we see the current schedule for normal temperature settings are from 5 a.m. until 11 p.m. daily. A recent enhancement to the capabilities of our building automation systems has been the installation of analytics software. The Copper Tree Analytics software monitors thousands of building automation sensor real-time data points and runs analysis routines on them. This automated fault detection and diagnostics feature pinpoints issues within the buildings, allowing the technicians to take resolving action immediately and oftentimes remotely, saving time and valuable resources. The analytics software is operating 24/7 and can reveal issues in a matter of minutes that would take a technical analyst hours and hours of data review to find. I will demonstrate the use of the analytics software. We will look at the Shaw Basketball Complex. On the main screen, the top 5 insights or system issues are shown. One of these is for HVAC unit VAV B12, which is a zone damper that regulates the amount of airflow into the room. We see the insight states that the discharge air temperature sensor is faulty, outside of acceptable range. If we look at the building automation system summary information screen for the VAVs, we see that the supply temperature, which is also called discharge temperature, is reading minus 97.5, which obviously indicates an issue with the sensor or wiring. A technician can take a new sensor to the site troubleshooting the existing sensor, and repair wiring or replace the sensor as necessary.
Utilities and energy management are a significant part of facility operations. Today we would like to highlight a few of the tech tools we use, ensuring the Wake Forest campus and community has reliable utility services to our buildings, and how we manage energy to be more efficient, saving money from operating budgets and reducing our carbon footprint to protect our environment. What powers our campus and keeps our buildings operating? Our campus electrical connection to Duke Energy's grid is a 20 megawatt connection and delivers about 40 million kilowatt hours each year to campus. This electricity keeps our lights on and our equipment running. Our primary connection to Piedmont Natural Gas supplies our 4 steam boilers at the central heating plant, where our 24/7 Utilities Operations Group continuously monitors campus HVAC systems. We consume this energy to provide steam for building heat and hot water throughout campus. Water often taken for granted when we turn on the faucet, whether at the tap, fountain, during a flush, or for irrigation. Water is an important utility to keep our campus processes running. Our supply from the City of Winston-Salem distribution system delivers over 85 million gallons per year to campus. How does facilities manage all this? You can't manage what you don't measure. Our utility sub-metering program consists of over 300 smart meters, including electrical, chill water, steam, and water throughout campus, which are continuously measuring how much energy our buildings are consuming, converting energy flows into digital signals across the network. This usage data feeds an energy database dashboard. From this, we can trend current usage and compare with historical usage or similar buildings, taking into account variables such as temperature, humidity, and occupancy. Based on energy usage at the building level, we discover good buildings and bad buildings. This allows us to identify waste and concentrate energy conservation efforts where needed. What is the largest single user of energy on campus? With respect to electrical usage and carbon emissions, that would be our air conditioning supply system. Our chill water plants, which keep our buildings comfortable, consume about 20% of our total campus electricity. With this in mind, we have taken chilled water efficiencies to the next level. The tool we use to do this is OptiCX, a cloud-based control system that optimizes our chiller plant efficiency. OptiCX monitors hundreds of variables within the chiller plants and continuously makes fine-tuning adjustments to equipment, using the least amount of energy possible while still delivering chill water to our air conditioning systems to keep our buildings comfortable. With the use of OptiCX, we have improved our chiller plant efficiency, which is measured in kilowatts per ton, or electricity per cooling unit. Smart metering and plant optimization technologies are just 2 of our many tools that have been an integral part of measuring our energy conservation methods and projects. Does all this innovation and technology really make a difference? Yes, these tech-savvy tools and systems have supported us as we push towards our energy reduction goals. Since 2007, we have reduced the energy unit intensity of our campus by 43%. Furthermore, we have reduced our gross carbon emissions by over 40%. During this same time period, our portfolio of building space has increased almost 50%. We are excited as we continue exploring new and innovative ways to conserve energy and reduce carbon, while providing faculty, staff, and students a comfortable working and learning environment.
Thank you, and I hope you enjoyed our presentation on the exciting technology we have in the Wake Forest University buildings. My name is Whitney Barker, and I'm the Media Coordinator for Facilities and Campus Services. We would love it if you checked out our website at facilities.wfu.edu, our social media at WFU Facilities on Facebook, Instagram, Twitter, and YouTube, And as always, you can call us at 336 758 4255.